Let's take a look at this example. This time we are going to do some calculations for series circuit which contains voltage source and two impedances, impedance Z1 and impedance Z2. We have given impedance Z1 and Z2 and voltage source. We're supposed to find Z total, I total, voltage across impedance Z1 and voltage drop across impedance Z2. So we're supposed to find Z total first. Remember that this is series circuit, so formula for Z total is nothing else, just sum of all impedances in this circuit. So I have Z1 plus Z2 because this is series one. This is equal, Z1 is equal 24 ohms and angle of 48 degrees plus Z2 which is equal 38 ohms and angle of negative 21 degrees. Use the calculator and you're supposed to get the value of 51.7 ohms and angle of 4.67 degrees. This is my Z total. In order to find I total, I'm supposed to use Ohm's law. I total is equal voltage source over Z total. Remember, current is equal voltage over impedance, where voltage source is equal 24 volts and angle of 75 degrees divided by Z total, which is equal 51.7 ohms and angle of 4.67 degrees. Okay, use the calculator. You're supposed to get 464.21 milliamps and angle of 70.33 degrees. This is total current in my circuit. Remember that in series circuit, current at every point of the circuit is the same. That's why I'm supposed to write KCL, Kirchhoff current law, for this circuit, which simply looks like this. I total is equal I Z1 and is equal I Z2. Remember, in series circuit, current is always the same. So, in order to find VZ1, I'm going to use Ohm's law. VZ1 is equal I Z1 times Z1, where IZ1 is equal I total, and we found that I total is equal 464.21 milliamps and angle of 70.33 degrees. So this is 464.21 milliamps and angle of 70.33 degrees times Z1, and Z1 is equal 24 ohms and angle of 48 degrees. Again, you're supposed to use the calculator, multiply these two values by themselves, and you're supposed to get the value of 11.14 volts and angle of 118.33 degrees. This is the voltage drop across impedance Z1. Next, we're supposed to find the voltage across impedance Z2. Again, we are going to use Ohm's law. VZ2 is equal I Z2 times Z2. Current times impedance is equal voltage. Because I'm looking for voltage across impedance Z2, I have to multiply the current which flows through the impedance Z2 times impedance Z2, which is equal 464.21 milliamps and angle of 70.33 degrees times Z2, which is equal 38 ohms and angle of negative 21 degrees. Again, you're supposed to use the calculator and you're supposed to obtain the value of 17.64 volts and angle of 49.33 degrees. Okay, so we got voltage drop across impedance Z1 and voltage drop across impedance Z2. And someone is going to say, okay, I'm finished. But it's always good to verify the answer. You want to always make sure that whatever you obtain is correct. You can verify your answer by simply using KVL, Kirchhoff voltage law, which says that the sum of the voltage drops across each impedance, I mean VZ1 plus VZ2, is supposed to give me voltage source. So let's take a look. So we have voltage source is equal VZ1 plus VZ2, where VZ1 we found is equal 11.14 volts and angle of 118.33 degrees plus 17.64 volts and angle of 49.33 degrees. This is equal 24 volts and angle of 75 degrees. Please notice that we obtain the value of voltage source exactly the same which we had at the beginning. So it means that whatever we have calculated is correct. So the problem is solved.